Hello! Today, you'll get to know the HDB framework, an innovative framework for automation development built on Automation Anywhere A360. Our framework offers everything you need to create robust, scalable, parallel-ready, and easy-to-manage automations. With our framework, your automations can follow a consistent pattern, with many features already built in, making automation development much easier. Our framework is represented here in this design document. It was built to minimize developer work, so he only has to configure the specific highlighted parts, and it is composed of a producer-consumer process pair. Let's start with the producer process. It handles extracting data from a data source and inserting it into a data pool. It is comprised of three main stages: initialization, processing, and finalization. The initialization has three steps. In the initial settings step, all configuration parameters important to the workflow functioning are initialized. In the start execution step, the start of the execution is registered in the data pool. Lastly, we have the initial application step. This is one of the points that require developer action, as all applications involved in the process are started. Therefore, the developer needs to code the startup of these applications. It is also here where one of the many features of our framework resides: the possibility of recording the whole process execution if the developer desires so. Having this type of video recording is very useful for ensuring that the entire workflow is working as intended. Moving on to the processing stage, we have two main steps: get transaction data and process automation. Get transaction data is responsible for collecting transaction data from any suitable data source that has to be specified by the developer, hence the highlight here. This can be an Excel spreadsheet, an email account, a website, among others. Process automation is then responsible for effectively inserting this data into the data pool as a row. Finally, we have the finalization stage. In this stage, the first step is close all applications, where all the applications involved in the process are closed, so that the machine returns to a clean state after the process is finished. Naturally, here the developer has to code the closing of these applications. And lastly, we have step execution, where the end of the execution is registered in the data pool. Now, let's move to the consumer process. We have basically the same structure as the producer, with the main differences being the processing stage. Here, get transaction data simply gets each row from the data pool and passes it to process automation. In process automation, the developer has to code the automation or automations that are to be executed. What I mean by this is that our framework has the capability of having a conditional logic implemented so it can run multiple automations that utilize the same applications using just one consumer process. For example, let's take a look at a CRM web application. Maybe the row retrieved by getTransactionData contains information about an account that has to be created on the Create Account section. Or maybe the row retrieved could contain information about a lead that has to be created on the Create Lead section. Both of these cases could be automated in separate sub-workflows and then added inside the framework. The logic defined by the developer would then take care of choosing which one to execute based on the data received. Pretty convenient, right? Needless to say that the data pools support these different types of transaction items inside it. All of the rows retrieved by getTransactionData are already allocated to a variable inside the framework. This way, the processing stage is simplified, as the developer doesn't have to worry about the format in which the row is retrieved, having to just handle this already provided variable. Additionally, in process automation, the developer has the option to enable item recording so that the entire row processing is recorded for logging and debugging purposes. The processing stage in the consumer process has three possible outcomes: success, business error, and application error. Success, as the name implies, is when the automation runs smoothly without any issues. A business error is when any of the rules that govern the process are broken. These rules must be defined by the developer when setting up the automation. For example, we can see here in the Create Lead section of the CRM web application that the last name field is mandatory, and phone numbers must only contain numeric characters. Both of these could be mapped as business rules by the developer to be followed by the automation. Any other exception not mapped would be then considered an application error. This could be caused by the internet going down during the automation execution or the web page simply not loading correctly, for example. In any case, all rows that get application errors automatically have a screenshot taken, also for logging and debugging purposes, and have a retry mechanism already implemented in the framework, where all the applications are restarted and the failed row processing is retried. This is because application errors are often solved by reloading the applications, so they are considered recoverable errors. Now, for you to see the actual implementation, I'm going to show both processes here on Automation Anywhere A360 being utilized in a CRM automation. After the overview, I will be executing the automation so you can see the framework in action. So here are the producer and consumer processes side by side, and as you can see, their layout is pretty similar. And for the producer, it is going to read from this Excel spreadsheet right here and insert each row as a row into the data pool. For that, we configured here the initial applications workflow that basically starts the Excel spreadsheet. Next, we have the get transaction data that gets each row from the spreadsheet and assign each column to variables that are later added to a list variable that will get inserted into the data pool as a row. And finally, we have here the close applications workflow where the Excel spreadsheet is basically closed. Now, for the consumer process, we start here in the initial applications workflow where the login to the CRM web application is performed. After this, we go to the process automation workflow, where we can see here the exemplified conditional logic to decide upon which automation to execute. In our case, these actions are disabled since we are only utilizing the CRM demo workflow. Also note here the variable inTransactionItem, a dictionary that contains the transaction item retrieved by the getTransaction data already formatted, ready to be used by the developer. Next, we have the automation effectively. We have here the CRM demo workflow that checks if the current item processing should be recorded, validates business rules, and after that, basically fills all the fields here in the create lead section of the CRM web application. And of course, submits the form. Finally, we have the close applications workflow that basically logs out of the application. Now, I will run the consumer process with some data from the already populated data pool so you can see it in action. All of the automations that utilize this framework can be visualized in a centralized dashboard that provides real-time data about many things, such as number of items newly created, in processing, abandoned, retried, failed, and finished successfully. We can also see the number of producer and consumer robots currently running, along with metrics regarding the number of items produced and consumed per minute that are also shown in two graphs that specify which robots are running which process. We are also able to see information regarding the bot executions, such as the name of the automation, the platform in which the bot is instantiated, bot name, type, number of rows produced, consumed, and retried, status of the execution, useful dates, error types and their corresponding messages, if any, along with the URL to the recording of the whole execution. Similarly, we have information about the queue items specifically, with their status, name of the bots that produced and consumed them, error types and messages, useful dates, and URLs to the recording of the specific item processing and to the screenshot in case of an error. We can see here in a retried item a screenshot of the moment where the error happened. and also the recording of a specific queue item. This queue items view is particularly important as it is a differential of our framework. No automation platform provides this level of knowledge about the execution of the specific items, most of the times providing only limited information about the bot executions. This view offers the highest level possible of governance, as you can see in maximum detail which items were processed successfully or failed, and more importantly, why, with the help of the error screenshots and recordings. That was it for our framework overview. If you have any more inquiries, feel free to contact us. We will also be providing more in-depth guides to configuring the framework so you can extract its whole potential. Thanks so much for watching.